My name is Siddharth Krishna. I lead the technical marketing engineering team for the Catalyst switching portfolio, as well as programmability and automation for enterprise networks. So if you look at what's happening in the world as we speak right now, the number one thing on organizations' mind is hybrid work and how to make that possible. As we've spent over last 2 years battling through the pandemic, folks have worked from home, worked from anywhere, and we are seeing organizations getting back to office now, right? Even Cisco is getting back to office as we speak right now. Now, what does that mean? That basically means that we need to make the office capable for the high-speed, low-latency kind of applications that we are seeing. You're getting into meeting rooms and you're going to have a bunch of the participants still dialing in remotely from remote locations, which basically means that you require high-quality video from office, and not just that, there are other applications that we are seeing which are gaining popularity, such as AR, VR, metaverse experiences, high density wireless, enabling all of these things. So important things to keep in mind. Now, companies also are wanting to make their workplaces smart and sustainable. They want to do things like people tracking, people counting, density tracking, and contact tracing. And that means there's a lot of sensor kind of endpoints, IoT endpoints that are needing to get connected to the network. And the network needs to be able to be capable of actually providing that infrastructure for that ability. Number 3 is hybrid cloud. This continues to take shape as we go through. Companies have already moved in an hybrid cloud kind of environment where they have migrated from on-prem to the cloud, a lot of their infrastructure, and we'll continue to see this grow as we go in, especially with remote site development and distributed access becoming popular going forward in today's environment. So we need to see how the network actually, kind of is able to provide those enhancements and feature set to be able to encompass all of these requirements. And this is really where the Catalyst 9000X models come into the picture and drive those requirements. So looking at a topology view of the network, right, we spoke about low latency, high density applications over Wi-Fi. Wi-Fi 6 and 6E, and we're going to talk about 6E much more in detail in this in a future session today. Require high density mgig ports, right? You will see that this is a prime topic that we are kind of bringing in, capabilities that we're bringing in, where we're moving our existing Catalyst 9000 portfolio to even greater capabilities of providing that higher multi-gigabit density. Smart buildings, I spoke about smart and sustainable buildings. This is where we require higher UPOE plus 90 watt port density. That is where we will see that we have done some enhancements in terms of providing those into the switching infrastructure that we're coming up with. We also see requirements on the server connectivity side, right? There are organizations that want to connect servers and use higher density 10G-based copper connections. Now, all of this is access, and all of this is about increasing the performance at the access. But along with this, we have to cater for the rest of the network as well, which is basically the pipeline between access and the distribution and core. And hence we require higher uplink, higher bandwidth uplinks on the access, as well as higher speeds, higher port speeds, scale and buffer on the core side as well. So as part of our launch, what we basically did was we introduced a few new products, right? Some on the wireless side with Wi-Fi 6E access points, but also on the Catalyst 9000 switching portfolio. What we're going to do in this session is really focus on the Catalyst 9300X, the 9400X, 9500X, and 9600X models that have expanded the Catalyst 9000 switching family. Now, without further ado, I really want to get into under the hood of these products. So let's start with Catalyst 9300X. The 9300X is the new high-performance access switch. It expands the family, expands on the family. This is not a replacement of the existing 9300 products, but in fact brings in new capabilities for customers who actually require those. This is so various models, but these are basically providing up to 48 ports of multi-gigabit / 10 gig rates, speeds on each of those 48 ports. Along with this, they also provide 90 watt on each of those 48 ports, right? They come with flexible uplink options, and we'll look at some of those details later. But internally, basically what these switches come with is the new UADP 2.0 SEC ASIC, which provides much greater bandwidth, up to 500 gig per ASIC. It provides capability of supporting port speeds all the way from 1 gig to 100 gigs, and that's where you see the uplinks, 100 gig uplinks that will come. It doubles the amount of stacking bandwidth from 480 to 1 terabyte, and I'll look at more details around that later. Beyond that, it also, and this is an industry first for these category of switches, it provides 100 gig of IPsec hardware-driven encryption right from the box, right? So it provides that capability of creating high-speed secure tunnels from site to site or site to cloud. We've also invested in enhancements in the application hosting infrastructure, and the CPU that resides on these comes with a Q80 engine that provides hardware acceleration for applications that run on top of it. These are orderable now, and let's take each of these aspects and deep dive a little further. So looking at the models, what actually is it that we are introducing, right? We've got 4 models totally on the copper side of the 9300X family. The first one is a 48HX, 48 ports of 100M up to 10 gigs on each of the ports line rate, along with 90 watt capability on each port. There is a data-only version of this, which is the 48TX, that is the number 2, and both of these are orderable today. There are 2 more models that we're coming up with, which is the first one is the 48HXN, which is basically 40 ports of up to 5 gig mgig and 8 ports of up to 10 gig mgig / 10G base T. Again, all ports UPOE plus 90 watts, and we have a 24 port version of this switch as well, where all 24 ports do mgig 10 gig as well as 90 watts. These 2 switches are going to be orderable in approximately May timeframe, and these are the new 9300X copper models, which are part of the launch. Now, besides this, 9300X was already introduced as a expansion model family. We've already had the high-speed fiber models, the 24-port fiber models that go up to 25 gigs, and the 12-port fiber model, which goes up to 25 gigs. And these were launched about 6 to 8 months ago, and really are replacements for the 3850 10G fiber SKUs, and can function well in a collapsed access / distribution kind of an environment if our customers choose to do that.
On these switches, you said it can be up to 90 watts of PoE per port.
Yeah.
Can I run the whole switch at 90 watts per port, or is there a power budget for the power supply that only allows me to run some of them in full power mode?
Yes, so all ports are capable of 90 watts. If you're running all ports at 90 watts simultaneously, then the power budget allows you to go up to 36 simultaneous 90 watt ports. I'm going to cover more details on that later in this slide.
With the new port speeds that you're introducing, is there new port names as well? Or
no.
have you kind of standardized a port name, like calling it Ethernet? I'm leaning down the automation path here. Is it, are people going to have to go in and modify their automation scripts with new interface names instead of a more generic name?
Yeah, so the naming continues to be the same as what is there in the current 9300 portfolio. To your point on whether we have standardized this as Ethernet / port number, That is something that we, kind of have not done as of now, but we're considering. But there's no change in the port name, so you will still use, 10 gig and 1 gig and things that you already used for. So if somebody is automating current 9300s or 3850s, then they should not see any difference in terms of the automation that they want, that they already have in place. So along with the switches themselves, we have also introduced higher speed uplinks, right? So now you have 4 more options, which are particularly for the 9300X switches. So one thing to remember is that the 9300X switches have their own uplinks, and these are those uplink modules. They do not use the uplinks that are currently provided for the 9300 and vice versa. So the 9300s don't use these uplinks. So it's a very important thing to remember. Now, looking at these uplinks, we have a 4 into 100 gig. This is really the highest density uplink module that is available in this line of switches, fixed enterprise access premium switches. There's a 2-port version of that. We are also introducing an 8-port 10 gig M-gig copper version of the uplink, as well as we have the 8-port 25 gig fiber, 2510 1 gig fiber uplink module that is already been shipping. So higher bandwidth of the access means higher bandwidth required on the uplink, and that's why you see these newer uplinks coming into the portfolio. Okay, looking at the back, just for in terms of understanding what is the investment protection, over here. There is nothing that changes at the back. So you use the same power supplies, you use the same stacking cables, you use the same stack power cables and the fans, right? So literally, I mean, there is nothing that changes. So you do not have to rip and replace anything that our customers already have, and they can add the new 9300X switches on top of their 9300 deployment. Now, how is that really being possible? That's obviously being made possible with Stackwise infrastructure. And that's my next point, right? We introduced Stackwise 1T. This is, again, the industry's highest stacking bandwidth in the fixed line of the portfolio. And the 9300X switches deliver 1 terabit of stacking when connected homogeneously, right? So if you are connecting a stack between 9300X models or between the copper and the fiber models on the 9300X, you get 1T of stacking bandwidth. Now, do we support mixed stacking? Yes, we do support mixed stacking as well, where you can stack with the existing 9300 models, but your stacking bandwidth is going to be, the highest common denominator, in the stack. So it automatically goes down to 480 gigs, as well as, the scale of the entire stack will run at the highest common denominator, which is that of the configured 9300 scale. Right, so mixed stacking is possible. Mixed stacking, and this is what really provides that investment protection that we spoke about to our customers, where they do not have to rip and replace their existing stacks and can continue to add these models, creating more collapsed kind of environments. I mentioned application hosting infrastructure and the enhancements that we have made. So a quick look at the enhancements that we have made over there, right? So what we've done on these switches is that we've doubled the RAM, we've doubled the cores that are available for application hosting. And not just that, what we've done is we have increased the bandwidth that is available for the connections of the applications to the data path, right? So if you're familiar with the concept of the app gigabit ports, we have now what is available is 2 of those ports, each running at 10 gig speeds, and versus 1 port running at 1 gig speed that is available on the non-X platforms. Now, what that does is that it gives more infrastructure, as well as it gives the capability of hosting multiple applications with that dedicated transport line to the data plane. So now what you could do, for example, is that you could host a 1000 eyes agent on the 9300X, as well as DNA Spaces IoT gateway on the same switch. And this would run without any issues, and we in fact now support multiple Cisco signed applications to be hosted on the switch. You could go ahead and also use the third-party applications, as a lot of our customers are already doing. So that's significant upgrade, and will open up possibilities of putting in more intelligence, running more intelligence onto the access layer. Now, this is a very key aspect, because it enables a lot of new use cases that our customers would not really normally be accustomed to when we talk about the 9300 line of switches. We are enabling 100 gig layer 3 encryption, IPsec encryption from the hardware of the 9300X switches. Right, this is the first time a vendor has done this on these category of switches, and basically it provides flexibility of now being able to run high-speed secure tunnels to do site-to-site and site-to-cloud kind of connectivity. Which is also, implying that now you could spin up branches and connect those branches in an automated way to the headquarters or to the data center or to colos without much intervention due to this, making use of this IPsec capability. Now, what we have done is, so one part is the platform support part, and we support the basic encryption, the authentication, and the basic feature set at this point, including IPv4, IPv6, OSPF, BGP, PBR support. We're going to continue to invest in this, and some of the other enhancements, such as support with BGP VPN, support for multicast routing, etc., is roadmap. So that is something that is going to come in the shorter term future. Besides this, we are also coming up with a full solution of actually automating this from the DNAC, right? So DNAC is providing day 0, day N automation workflows to be able to create those connections from branch to a site, so basically site to site, or a branch to a cloud, for example, Umbrella, to provide that SIG functionality for the branch. So this solution is in the works and is going to be available very soon as beta, but we are working towards making this available later in the year for our customers. Now, one important thing is that this solution overall, does consider consolidation of various different things into a branch by the Catalyst 9300X, and is suited or is applicable for customers who are not really, for those select customers who are not really looking at SD-WAN, right? For all SD-WAN customers, the lead motion is still to go with our routing portfolio that supports SD-WAN. There should not be any conflict over there. This is for those select customers who are not interested in deploying SD-WAN and have lean branches where they want to do this IPsec connectivity.
With this, using IPsec for layer 2 and layer 3 segmentation, how does that fit into what Cisco's doing with SD access for the microsegmentation there? Does this encrypt, help encrypt what's going on there across the, I think it's VXLAN tunnels and SD access, or does this work separately?
So this is both applicable for SD access as well as BGP VPN. We're also offering the open BGP VPN solution, right? So that is something that we do not support today at FCS, but we're working to basically get it supported with VXLAN. And that's what it basically means over here.
Okay, thank you.
That's why you see that it's roadmapped. Yeah. Okay, now let's look at the 9400X. Now, the first thing I want to kind of talk about over here is that when we say 9400X, it's not a new 9400 chassis, right? We're talking about 9400X in terms of a new generation 2 supervisor that we're introducing and the generation 2 line card that we're introducing. Our customers do not need to change their chassis. They should continue using the existing chassis deployments, and all of this is basically adding to the existing functional set, the existing throughput set that they get. And this is only enhancing that, as we promised earlier, in terms of investment protection with the modular platforms. So with the existing supervisors, what we can see is that the supervisors currently use UADP 2.0 XL ASIC and deliver bandwidths from 80 gigs to 240 gigs based on the chassis type that is in question. What we're now doing is we're introducing a new set of generation 2 supervisors, the SUP2 and the SUP2 XL, which are built using the UADP 3.0 SEC ASIC. And can now provide bandwidths of 480 gigs per slot with the Supervisor 2 XL and 240 gigs per slot with the Supervisor 2. Not just the bandwidth. So, of course, one aspect is the bandwidth, and that is being basically done using the UADP 3.0 ASIC, where each ASIC now provides 1.6 terabit of bandwidth compared to the 240 gigs earlier. It provides support for speeds of 1 through 100 gigs, and you will see 100 gig uplinks coming into these supervisors. It also provides increased scale. So both max scale and route scale has been increased. And this is basically the family of ASICs that have been used on the 9600 Supervisor 1, right? So you will get increased scale, you will get increased buffer. As well as if you see the SEC that has been included in the UADP 3.0, it is the hardware capable of doing things like IPsec and MACsec. So that is hardware capability that we're introducing, and software support of those things are going to be done sometime in the future. But overall, with this, it provides that maximum investment protection where you can migrate or replace your existing line cards to the next generation, and you will see the benefit of this bandwidth being realized also for the existing line cards, right? So existing line cards do get a considerable bandwidth bump, and that's what we'll look at a little bit more in detail as well. So what are we really coming up with in terms of the supervisor offerings, right? So there are two supervisor offerings as part of this generation 2. One is the Supervisor 2 XL, which is our lead supervisor, providing 480 gigs per slot of bandwidth for each of those line card slots. The second one is the Supervisor 2, which provides 240 gigs of bandwidth per slot for any chassis type, right? That's the important part. So now you're not restricted to 80 gigs on the 10 slot chassis. Even if you have the 10 slot chassis, you can go up to these bandwidths. Looking at the front a little bit, these supervisors come with 100 gig uplink, so you have 400 gig slots as well as 4 25 10 gig SFP slots as well. And you could do bandwidths of up to 400 gig simultaneously on the uplinks, which is also a considerable bandwidth boost.
In the past, we've run into things where these supervisor engines have all these lovely ports on the front, and then you find out you can only use part of them, or depending on whether you want blocking or non-blocking. Are these all non-blocking ports?
All of these are non. So that's the beauty of the power with the new ASICs. These are all non-blocking ports, okay, right? So when I'm saying the bandwidth supported for this supervisor, right now these are all non-blocking ports. Yes, if you are going to use two supervisors, and that is what my next point was, if you're going to use a dual supervisor configuration, in that case your uplink bandwidth will be split between the two supervisors, right? If you're using a single supervisor, you'll get all the 400 gigs uplink bandwidth for use. Right, so that doesn't change from our existing family. When you're using a dual supervisor configuration, the uplink bandwidth will split between the two supervisors. So you can do 200 gigs and 200 gigs connection on each of those two supervisors in an SSO configuration. So at FCS or at launch, these supervisors have parity with the SUP1 XL from a feature set, but there are some exceptions over here, and those exceptions are listed out. I think one main exception over here is the Stackwise virtual support, which we are working on bringing it in soon in a subsequent software release. There are certain other things, and all of these things are being worked upon, and we have them on the roadmap, and they should be coming in the short time future. Right, but other than that, it has, from a feature perspective, it has parity with the Supervisor 1 XL, which is the previous generation supervisor. So we spoke about the supervisors. We are also bringing in two new line cards, and these are generation 2 line cards. One line card is the 48HX, similar to what we discussed on the 9300 X side. So this is a 48 port N gig, 10 gig line card and delivers 90 watts of power on each of those 48 ports, right? You can go up to 384 M gig, 10 gig ports and 384 90 watt ports using this copper line card. The other line card on similar lines, but is a fiber line card. So you can do 48 XS line card, which basically provides 10 gig fiber connectivity for, collapsed access distribution use cases or fiber to the desk use cases. Now, the key difference is that these are all line rate, right? So you could do 480 gigs on one line card. That's what the new supervisor actually enables. These line cards work with the newer Gen 2 supervisors. I mentioned a point that there is a bandwidth boost on the existing line of the line cards as well, and this is really a view of how that is basically getting enabled, right? So if you look at the three rows, the bottom three rows, you get at least 3 times of bandwidth uplift with the newer supervisor 2 XL for the 10 slot chassis. So you go from 80 gigs to a minimum of 240 gigs per line card. You get at least 2 times bandwidth uplift for generation 1 line cards going from 7 slots, from the 7 slot chassis, for the 7 slot chassis going from 120 gigs to 240 gigs, right? So this is, and of course the newer line cards give you 480 gigs all line rate. So this is significant, and this is very important for our customers when they are trying to grow in their modular architecture journey. Okay, so we introduced the 9300X with a lot of, with high density 90 watt capability. We also have it on the 9400X. What does it mean from a smart building perspective, right? So on the 9300X, and this is to your point earlier, Reza, right? The significant difference is that you can now do 36 simultaneous 90 watt ports as compared to 32 earlier on a standalone switch. And what it also means is that you can now do 288 ports in a stack of 8 switches, which is higher than what the regular 9300 models today actually offer. On the modular side, the supervisors are capable of doing fast and perpetual PoE. This is something that we were not able to do in the supervisor 1 architecture, and this is something that is hardware capable on these, and the software support is going to follow. But important point to note that you can now do perpetual and fast PoE also on our modular offering, as customers would be, kind of doing it on using our fixed offering already. And besides this, we have ton of innovation that is coming into the smart building space. You're already aware we've done stack power for a long time. We have the DNS Spaces IoT gateway functionality on the access switches 9300, 9400. We have advanced power and PoE analytics via the DNS Center, and we also have AI endpoint analytics and trust analytics, which is going to be covered in a separate session later today. Okay, so that was our 9300X and 9400X high performance access expansion. And like I said, to enable the high performance access, you also need to think about advancement at the core distribution and core layer as well, right? You need higher speed ports, you need higher speed downlinks, you need higher buffers, and also, basically, being able to fulfill that gap of, an offering in the XL space where you got, a lot of buffer space, a lot of routing capabilities, and so on and so forth. So that's the basically pretext of how and why we're now talking and looking at Silicon One. So Silicon One is a Cisco offering. It was introduced in 2019. Particularly, we want to talk about the Q200 ASIC, which is the latest in the generation of the Silicon One portfolio. right? And provides that extra capability of that XL scale that we are looking at for the core and distribution platforms. Silicon One basically combines the routing capabilities in terms of the scale and the switching performance into one solution that can now be used to provide an XL offering in the distribution and core space. And this is the first time that we are doing this in the campus environment. The service provider team has had its offering, but we're bringing the Silicon One Q200 in the campus for the first time, right? And we'll see how this translates to the products themselves. But looking at the ASIC itself, the Silicon One Q200 ASIC particularly provides up to 12.8 terabits of bandwidth in one ASIC, right? So that's a lot of forwarding performance that is packed into one ASIC. It provides deeper buffers, larger buffers, 8 gigs of buffers that can be used for queuing purposes, and it provides a very large routing scale, right? So the ASIC itself provides up to 10 million IPv4, but in the configuration that we are going to be using it on our 9500X and 9600X offerings, it provides 2 million route scale, which is good for the internet routing table, and that also kind of leads to a slight, that leads to a positioning conversation, and I'm going to kind of get to that as to where these offerings are catered to from a positioning perspective. So these ASICs are the lowest in terms of watts per gig, watts consumed or power consumed per gig of bandwidth that is provided. They are programmable using P4 programming language, as well as are built with a multi-slice architecture that provides flexibility and scale. And these are the ASICs that we are using to come up with the newer expansions or the additions to the 9500 and the 9600 families with the 9500 and 9600X platforms, right? So the 9500 and the 9600 Supervisor 1 are built were built with the UADP 3.0 optimized for feature sets, right? They delivered on these on the speed requirements that we usually see in the core, but primarily are a non-XL offering, right? Non-XL offering, but provide all the services that were required or we would normally see from our customers for a core/distribution platform. The 9500X and the 9600X Supervisor 2 are optimized for scale and performance, and that is why they use the new Q200 Silicon One ASIC. They now support speeds of 50 gig, 200 gig, and 400 gig for the first time in campus, right? So with this portfolio, we are bringing in 400 gigs for the first time in the enterprise campus. And there are some nuances over there, like the hardware is capable of 50 and 200 gig, but we are waiting for the optics to bring in that software support. So those particular speeds are a roadmap item, and we'll do that. But today at FCS, you are getting the 400 gig ports, full capacity, full line rate performance with these switches. The scale goes up higher. I mentioned that the Q200 Silicon One ASIC provides that extra scale. So now you go from 128 to 256 max. You go from 256K routes to 2 million routes, and you get the additional buffer space as well, which is much higher than what the UADP 3.0 actually offers.
You had mentioned that these ASICs are P4 programmable, yes?
They are P4 programmable, yes.
How is that exposed in the operating system? Is that something that I can control directly, or is that something that I have to partner with Cisco to get access to with some kind of like a special development kit?
I believe there is a development kit, and one would need to partner with Cisco. But I would let the Silicon One team actually comment on that a little bit more, and we can provide the details. Okay, So we're looking at services. We are supporting on these switches. We're supporting the set of services, the distribution and core services and solutions from a feature set perspective. But we're adding to it as well. So the new thing over here that the Silicon One is capable of doing the platforms are capable of doing is WAN MACsec, right? This is not something that our current generation 95-9600 switches actually offer. Other than that, the feature set kind of remains same, and we are at parity at most of the things that the current generation is capable of. There are some features such as NetFlow, NAT, etc., which the systems are hardware capable, but we are going to be coming in from a software support perspective later. So let's deep dive into the core switches, the platforms themselves now. The 9500X is our lead fixed core offering for XL scale now, right? So this 9500X is a 28 port, 100 gig port plus 8 400 gig port offering, right? With the Q200 ASIC, now the total capacity that is being offered goes up almost 2 times when compared to the existing 9500H high performance switches. These switches deliver 6 Tbps, and if you do the math, that is the actually overall bandwidth that is required for those number of ports. And you could even run the 400 gig ports at 100 gig speeds, and I'll look at those configurations a little bit later. I did talk about the scale, uplifts, etc. So all of those come with the platform. And like I mentioned, since this is for XL deployments, from positioning perspective, these are for for core or campus edge use cases where you would want that scale and buffer going outside of the campus, and these switches are now ready for those kind of deployments. Now, these are not, like I said, because of this, these are not replacements for 9500 high performance. These are additions for XL use cases. For non-XL use cases, the high performance 9500 switches on the left are still our go-to platforms. Right, so looking at the details a little bit more, we have 100 gig ports on the left and the right, and then these are 2800 gig ports being able to deliver speeds of 100 gig as well as 40 gig. We have the 8 400 gig ports in the center being able to deliver speeds of 400 gig, 200 gig, and 100 gig. 200 gig speed, like I mentioned, is something which is roadmap for software support. And the PHYs on these switches, support the WAN MACsec and the PTP and PTP v2 IEEE 1588 functionality as well. Hardware capable, software support to come in future. Now you could break out. I mean, obviously, these are high-speed ports, so there have to be certain breakout options that are possible. You can break out the 100 gig ports into various breakout options. But the thing to remember is over here that when you're breaking out these ports, you can break out the top ports in each column, right? So when you break out the top ports in each column, the bottom ports become unusable. Those cannot be broken out. The ports themselves become disabled, right? So currently we support 4 into 10 25 gig breakouts. We also have breakouts on all 8 ports in the center, all 400 gig ports. We currently support 4 into 10 25 gigs with 8 into 10 25 gigs and 4 into 100 gig breakout supports coming in the future.
Herr Nelson, and I hope I'm pronouncing his name properly, has asked a question on Twitter about the Q200 chip, and he said it seems like 10 gig is the lowest line rate speed possible on that. He's wondering if there's any chance of providing 1 gig port speeds with the Q200.
So at this, the Q200 ASIC does not support 1 gig speeds, unfortunately, right? So yes, our offerings currently support up to the lowest speed that it supports is 10 gig. We are looking at certain other possibilities in terms of This is a request that we are seeing, right? So we don't have a solid solution for it right now, but that's what you have on offer at this point, which is the lowest speed of 10 gig on these ports. Yeah. These switches also come. This is also something that we have done first time on the 9500 or the Catalyst 9000 platform is reversible airflow, right? So these switches come with an option where you can choose a particular fan which decides on the kind of airflow that you want. You could either do front to back or back to front. And we've seen this request from customers where they want to change the direction of the airflow on the switch, which was not possible till now. But in this, we are enabling it with the fan, with the type of fan that you can select while ordering the switch. Okay, moving on, Catalyst 9600X. This is, again, like the 9400X, same chassis, generation 2 supervisors, right? Again, using Silicon One ASIC, where now these supervisors actually take the advantage of the full bandwidth that is provided by the Q200 ASIC, which is up to 12.8 Tbps, right? So you go up from 4.8 Tbps to 12.8 Tbps, which basically increases the per slot bandwidth from 1.2 to 3.2 Tbps, which is almost a 3 times increase. What this also does is that it increases the speeds that are being offered with the current generation of line cards, right? So if you have a 100 gig line card or a 25 gig line card, you will be able to get higher speeds on those line cards just by replacing the supervisor from supervisor 1 to supervisor 2. So that's the new supervisor, which is a supervisor 2. Again, also supporting 400 gig speeds, right? So the supervisor does support 400 gig speeds on the modular side as well. And to add to this, we also are coming up or have come up with the newer line card on the 9600 model family, which supports 400 gig ports, and I'm going to look at it next. So the newer line card is a line card offering basically which comes with 400 gig ports, 200 gig ports, as well as 40 SFP56, which is 25 gig ports and 50 gig ports. It can be used in 2 configurations, and this is one line card that works both with the previous generation and the new generation of the supervisors. With the new generation of the supervisors, it provides 3.2 Tbps. With the existing generation, it provides 1.2 Tbps. So you need to keep that in mind. It's a combo line card, so it's an offering for our customers where they do not have to burn a line card slot on the 9600 just to provide, for their uplink bandwidths. They can use this for both their downlinks and uplinks because you get those select high-speed ports. I mentioned this. These are different port configurations for the supervisor 2 and supervisor 1. I'm not going to go into details, but basic idea is that when you're using it with the older supervisor, certain ports get disabled, and you are able to get 1.2 Tbps with speeds of 25 gig and 100 gig. Important slide to kind of finish this off. Generation 1 line cards are supported with supervisor 2. I mentioned that earlier. You will get a bandwidth uplift on the generation 1 line card. The 100 gig line card, now you will be able to do full 24 ports of 100 gig, and you will be able to do 50 gig ports, 50 gig speeds on the 48 port for 50 gig line card as well. The Silicon One does not do MACsec in the ASIC, so the PHYs on the line cards are actually doing that MACsec. So that's one thing to remember, right? So if you're using an old line card with a new supervisor 2, that MACsec functionality will not work, but any other combination you will have MACsec working. General, recap on positioning. Like I said, our customer should continue to use the 9600 supervisor 1 offerings for non-XL deployments. These switches are good enough in terms of their services and scale. But if any customer is looking for an XL deployment with additional buffer, 400 gig speeds, additional scale, right? That is where the newer 9500X and 9600 supervisor tools should be used. With that, I'd like to quickly summarize in terms of what we just spoke about. We spoke about multiple offerings, the expansion on the Catalyst 9000 portfolio, the 9300X and the 9400X on the Access, 95 and 96 on the Core. And with that, I want to also showcase this portfolio slide with the expansions where we are adding models on the 93, 94, 95, and 96, and all of these are things that we have technically spoken about in this session. Thank you.